tutorial. So today we'll be answering this question under simple harmonic motion, and the question is simply asking us the wheel in the simplified engine of figure P13.23 has radius A equal to, okay, so we have been given, of course, the saying that the radius A has been given to be 0.255 K 0 meters. Okay, then we have been told that the angular frequency is simply 12.0, of course, in radius per second. And we have been taught that, of course, at t is equals to 0, when x is equivalent to the amplitude, we have been taught to calculate the piston's position, the velocity, and the acceleration. So to answer this question well, also don't forget that the time has been given on which you are supposed to calculate everything, and the time is said to be 1.15 seconds. Now, one thing that you must understand is this: for you to calculate the position, you must be able to know this formula. Position is equal to the amplitude cosine Wt. Okay, now the amplitude has been given to be 0.25 cosine, what is omega? It is 12 in radians per second multiplied by the time, which is 1.15. Okay, so whatever you find here, that is the answer. It must be in meters. Must be in meters. I get to B. This was A. Let's get to B. They are saying we calculate the velocity. The velocity under simple harmonic motion is given by this formula: A W sine Wt. Okay, so for this one, the amplitude, of course, is the same, 0.25. Omega has been given to be 12 sine omega multiplied by 1.15. Whatever answer that you're going to find when you do this, it must be in meters per second. For C, acceleration under simple harmonic motion is given by the formula negative omega squared A cosine Wt. So of course, omega is simply 12 to the power 2. The amplitude has been given to be 0.25 cosine. This is going to be omega multiplied by the time given, which is 1.15. And of course, whatever you're going to find is going to be meters. Okay, meters per second squared. So this is just how you go about this question. it is very, very simple. Okay, so some books, the acceleration is found by this formula. Sometimes they'll write it like this. For the acceleration, and this formula comes from this. We know that the force is equal to ma, but then remember that under Hooke's law the force is equal to negative kx. So while there is this force, I can replace with ma, then negative kx. Then I can cancel with over m, and I'm going to remain with the acceleration equal to negative k over mx. Now remember that omega, let me just try to wrap this. Okay, remember that omega is equal to the root of k over m, meaning omega squared is equal to k over m, meaning while there is k over m, I can replace with omega squared, so it's going to be negative omega squared x. But then remember that this x, accordingly to the question, it is equivalent to a, so the acceleration can also be found using this formula. While there is x, I can replace with this, then everything is going to be meters per second squared. So the rest is just a matter of replacement. Otherwise, this is just how you go about this question. Thank you so much.